Hi, good afternoon. It's Adil Zainulbhai, Chairman of the Capacity Building Commission, and it is my very, very great pleasure to introduce our next webinar, which is by Anand Ramamurthy. If there is one person who knows a lot about semiconductors in India, it's Anand. He spent his entire life in it. He started out as a graduate of IIT Roorkee and an alum of Harvard Business School's AMP program. He has worked in multiple semiconductor companies, and as I understand it, he is also heading Micron today in India. They've grown very fast in India. He has led Intel's South Asia business for semiconductors and cybersecurity. He's also the managing director of Harman India. He served as managing director of Harman India. He's currently on the boards of several startups and several high-tech companies, and is also part of Telangana's Investment Council. And as you all know, Telangana is trying to play a major role in semiconductors. So he has worked in many, many different areas, has spoken a lot at NASSCOM and NASSCOM events. He's had the pleasure of being interviewed on CNBC's Young Turk program by Shireen Bhan, which is always a sign that you have achieved something. So with all of that, I'm very delighted to have him as our next speaker. What he's going to talk about is really, this is a beginner's guide to semiconductors. It's for someone, he's going to talk about what is the semiconductor industry, how did it evolve, how did it become so big, why is it called the new oil, why is everyone pouring so much money into it, why are countries like Taiwan and Netherlands, whom one would have never thought about as super high-tech 20 years ago, why are they suddenly so critical in the semiconductor supply chain in the world? And he'll talk a little bit about what India is doing in semiconductors today, and then talk about how the semiconductor industry is likely to evolve over the next 10 years. The one thing that he said he will not talk about is how to make investments in the semiconductor stocks. So please don't ask any questions about that. Other than that, you can all send in your questions, and after he's finished his talk, he will be very happy to take questions from us. And periodically I will also intervene if I think this is getting a little too technical, or that there are some very urgent questions coming in from the audience that need to be addressed at that point. So with that short introduction, Anand, the floor is all yours.
Wonderful. Thank you, Adil. Thank you very much for that very generous introduction, and excited to be here. And it's a wonderful initiative to be able to share access, insights and information with a wide category of government employees. So I'm really privileged and feel good about doing this. So maybe Susan, the next slide. Yeah, so this is the broad agenda that I have in mind. I'll try to do a little bit of a small primer on semiconductors. This is a very vast subject, so I probably will touch on what does it mean when someone says logic or memory or analog. So some key acronyms, more of a 101 primer. Many of you probably are very aware. Some can always go back and then do a little bit of a deep dive. Good to talk about what are some of the current challenges, opportunities, and different approaches that many of the semiconductor players are taking. We'll talk about the Indian semiconductor landscape, some market outlook, then of course open up for any questions, comments, or intervention that Adil may have. So we'll move to the next slide. So this quote is interesting because this is by a gentleman called Dan Yergin, who is a Pulitzer Prize winner. And he's a gentleman who has been following the energy market very closely. And obviously, as we all know, oil has been referred to as precious commodity that can actually change destinies of nations. We have seen oil change the destiny of many countries in the Middle East, in Saudi Arabia, and many parts of the world. And still today, it's an extremely important category which can lead to wars, geopolitical shifts. And what this quote kind of, I was trying to find out who was the first person who coined this term, semiconductor as the new oil. Obviously, there are no rights over this particular quote, but looks like this was one of the many, visible interventions of referring to semiconductors as being so fundamental, so foundational to countries, to economies, and to companies. In fact, I have a fun way of saying it. I look at semiconductors as the pizza base. India is becoming a pizza eating country, and everything on top of it are toppings. So what kind of applications you build, but at the heart of it, all electronics, all devices, everything that you connect, engage, immerse yourself in is driven by semiconductors. So no wonder this session is termed as semiconductor as being the new oil. Okay, next slide. So a bit of a primer, apologies if some of you are very familiar, and in case this is way too detailed, you can ignore. But when you think of semiconductor, there are different ways of slicing and dicing it. As the name indicates, semiconductors are a class of materials that are neither fully conductive nor fully insulated. They're not insulators either. So they stand somewhere in between. And if you have gone through the periodic table in your mid-school or high school, you would have heard of silicon, a group 14 class element with 4 valence electrons. I will not go any further there, but the idea here is silicon today is still 90% of all semiconductors. Obviously, newer category of semiconductors in the form of compound semiconductors, different other elements have been tried. People have also tried organic semiconductors made out of polymers. Some of them are conducting under certain conditions. But some of the simple ways of looking at the categories of semiconductor is digital and analog. And in the digital world, you have 2 parts. There is the logic part. So to make it simple, when you think of companies like Intel, Qualcomm, and NVIDIA, they're largely playing in the logic part of the equation, which is, and when you think of someone like Micron that I represent, or Samsung or SK Hynix, they play in the memory part of the semiconductors. So there are companies that do both. There are companies that do, Micron, for example, only does memory. We don't do logic. And so the digital part of semiconductor ecosystem consists of the logic part, which again can be thought of at a very high level as a mix of CPUs, GPUs. You may have heard these words, but just to make them more relevant, thinking of CPUs, again, think of Intel making processors for a very long time. NVIDIA, which has been in the news of late, is one of the larger players in the GPU segment. And if there is one simple way to think of CPUs and GPUs, CPUs largely tend to transact and do calculations in a more linear, sequential way, while GPUs, because of the way they are designed, can do stuff in a parallel way. There's a lot of parallel processing happening in GPUs, which is why they are very useful, as the name indicates, in graphic rendering of pixels, and more recently, a very big player in the evangelization of AI. When you think of AI, a lot of that machine learning and AI logic will be driven out of GPUs because of how our mind works, how AI systems work. So, and the memory side, of course, we have NAND and DRAM. A lot of research has been happening to find a class of memory that is somewhere in between DRAM and NAND. That continues to take place, but for most practical purposes, the world is in 2 camps. DRAM is your system memory that you have in your laptops and phones, and NAND provides the storage that you need for being able to save and store files. Another manifestation of semiconductors is what is referred to as a system on chip. As the name indicates, the intent on an SoC is to be able to bring a lot of different pieces of logic, memory, and compute all together in a larger format of silicon, very often used for, if you're thinking of your automotive infotainment system or your smartphone, there's a very high probability it's being driven out of an SoC. So, and then this is all digital that I was talking about. The world we live is analog. We also use a lot of chips for being able to sense a lot of things. We want to sense heat, temperature. We want to also manage power in circuits and electronics. So that's the analog world, or what also referred to as mixed signal world. So semiconductors, digital, analog, analog/mixed signal, also includes a category called sensors, because the way to think of something is you want to capture in the analog world you're capturing heat or temperature or some kind of a trigger. Then there's a compute part, and then there's a transmission part, and those are the elements involved in the typical processing of any data. So Semiconductors obviously have been kind of, the first transistor was built way back in the late 1940s. William Shockley and team has been, there was Fairchild Semiconductor. Then, of course, Intel started the era of compute and in the late 70s, 80s, and 90s. Of course, today we have a fairly large set of people playing in semiconductors. Still a very niche, energy-intensive, capital-intensive sector, but clearly very foundational and fundamental to almost everything we do today in our lives. So that's kind of a quick little primer on what semiconductor classes are out there. Next slide. So this one is a little more of, we've been quite obsessed about, hey, semiconductor has obviously a design part where we are trying to, write down code in a high-level language and be able to, design a chip, as we call it. And then there is a manufacturing aspect to it. And in manufacturing, obviously, you can break it up at a very high level into two parts. There is the front-end manufacturing, where the wafer is involved, and there is what we call in our parlance the back end, which is essentially where we do the packaging, testing, assembly, and then the shipment of the final silicon. So the front end and back end fabs very often are co-located. Sometimes they are not. You could do the front end in a different part of the world and do the back end in a different part of the world. You could do them together. There is no necessity that they have to be co-located. And in the manufacturing world, all of you must have heard of wafers. Wafer, just like a biscuit wafer, is essentially the basic prime material on which the entire dies or circuits are constructed. This is made out of silicon, and then you kind of put a small oxidation layer on top of it. There are lots of interesting steps like photo, litho, etching. I won't go through all of it, but essentially what you want to do is you have a 200 millimeter or a 300 millimeter large wafer. You have the ability to, whatever you designed, to be able to transmit the design or etch it and do a lithography and put it on silicon wafer, and then be able to test for functionality, and then of course package, assemble, and ship it out. It's way more complex than how I just explained, but it's safe to say that this is the secret recipe, because this is extremely complex. It involves a very significant ecosystem that can make no one company. You should think of Semiconductor as being a great example of collaboration between all the different ecosystem partners. Very few companies can do everything and anything from start to finish. So there's a lot of collaboration between equipment vendors, design vendors, manufacturing vendors, and I'll come to that in a bit. But at a very high level, it's a multi-step process. From the time you start a wafer to get a finished product, it can take anywhere between 20, 30, 40 weeks. And this is assuming, the more complex the chip is, the more layers does it have, it takes much more time for the silicon to come out. So fabs are located all over the world. I'll talk about India's aspirations in this area, but clearly something where India has already made a good start, and we are hopeful that we will make more progress in the coming years. Okay, next one. I think by now all of you know that semiconductors, as I mentioned in my opening comments, find applications everywhere, right? If you're driving a car, of course, you have chips everywhere in the car, but the highest concentration of chips happen to be in your safety devices, in the infotainment devices, in the radio that you play. These are all places where you can find a lot of electronics. And all of you may have heard about Moore's law, which says that the number of transistors on a given piece of silicon has been multiplying or doubling or literally for the next in 18 or 24 months. More than the timing, what it indicates essentially is the industry is all about trying to add more and more transistors on a single piece of silicon. The more transistors means more computation, faster computation, quicker movement of data, and quicker results. So likewise, in every application you can think of, be that be in cars, your smartphones, your networking and telecom equipment, in health technology, in education, you name it. Almost all of these sectors have significant applications for chips, as we tend to call them informally. And we have a very large ecosystem of companies actually supporting these different companies. And chips are, the bread and butter of these sectors. Okay, keep going. Next one. Some more examples. Susan, next slide. Yeah. So this one is what I was referring to. It's a very complex ecosystem, much more complex than what you see right now on the screen. I'll quickly go through all these categories. Integrated device manufacturers. These are companies like Micron, Intel, Samsung, Texas. There are many more. These are just some examples that I'm giving. These are companies that actually are designing chips and also manufacturing this inside the company umbrella. So that's why it's called an integrated device manufacturer. Sometimes they do it because they are good at it. Sometimes in the case of Micron, we cannot outsource memory. Memory is so niche, so in-house, it has to be completely in-house. So Samsung, Intel, SK Hynix, we all do most of our memory manufacturing in-house. And sometimes we outsource some part of logic to external foundries. So that's the first class of ecosystem players. Then we have fabless companies. These are companies that focus largely on design, the likes of Qualcomm, NVIDIA, Broadcom, MediaTek. Their specialty is being able to design the appropriate chip for a given application. And they very often work with the third category of people called the foundries. This could be TSMC, UMC, SMIC. These are people who actually manufacture as a service. They put a lot of investment in R&D in building new technology nodes. We are fast moving below 10 nanometer, which is actually becoming very difficult from a physics standpoint. But the fabless companies design and they work with foundries to ensure that the final silicon comes out. A very important partner in the ecosystem are equipment players. Adil and I were chatting earlier today, and he was talking about this company called ASML in Netherlands, Applied Materials, Lam, there are many more. But these are the people who provide people like Micron, the required equipment that we use in our fab for different processes. It could be photolithography, for etching, for deposition, all the different steps involved in manufacturing. The equipment players are the ones who are actually providing us with equipment. Then, of course, a very critical part of supporting all of this are the horizontal material suppliers. These are chemicals, gases. There's so much that is needed in a typical semiconductor manufacturing background. So as you can see, I talked about the collaboration that is needed. I'll take the example of Micron since I represent Micron. We obviously work with TSMC and other foundries for some of the logic part of our portfolio. We, of course, are customers to all the equipment players. Then, of course, we have a whole variety of suppliers of gases, materials, substrate, packaging material, you name it, that helps us to build these wonderful, wonderful chips for multiple applications. So a great example of a complex and a very, very connected ecosystem. Okay, next slide, please. Shifting gears a little bit, I gave you a little bit of a primer on what semiconductors are, what is involved in the ecosystem, what kind of manufacturing processes are led. Good time to just very quickly look at probably some of the biggest challenges we find in the area of computing, which is where semiconductors play an important role. I'll keep it at a high level, and then based on interest, we can dwell deeper. The first challenge that we have is it's getting better and better, but a lot of computing was very general purpose. And what I mean by general purpose is these are essentially application-specific computing. So, it's computing for data centers or for automotive. But what is happening now is data, there is an increase of velocity, variety, and the volume of data that we all have to play with. So the old general purpose computing systems may not work very well. And we are looking at newer architectures which are more focused, which are more data-centric and not application-centric, which is why you have this new era of devices that are more on the edge, AI edge. The GPUs are a great example of trying to differentiate and evolve over traditional RISC compute engines. So clearly, one trend that we're seeing at a macro level is making our processing and computing more and more data-centric and not application-centric. There are two important aspects in compute. I talked about logic and memory. And what often happens is a lot of the time and energy is lost in moving data from memory to the processor, to the compute part. And that is wasting a lot of time, energy. Almost 60% of energy is lost in just moving data bits rather than in actual compute. So there are lots of interesting approaches coming where this amount of power consumption has to come down. If there is one important trend in semiconductors, it is low power. Thanks to the whole AI revolution, the volume of data we're dealing with has become humongous. The compute needs are becoming both at the edge and at the cloud significant. And what becomes very important is to keep power in mind. And there are probably 100 different ways of managing power at a component or at a system level. but the idea of reducing power more and more becomes very important in semiconductors. I've talked about new application landscape, AI being the cheerleader there. I talked about energy constraints. Also remember, as we're talking about hardware, there is also an area of software where the security landscape, our chips are also becoming very vulnerable to security attacks. We used to be saying that, hey, security attacks typically happen at the software and the stack level. But now in the memory space, for example, there's a very famous security exploit called the row hammer. I won't go into the details of it, but what I'm trying to tell you is some of the hackers have the ability to get into the hardware at a bit level and be able to flip bits. So long story short, we are going to design a lot of amazing silicon in semiconductors. We have to keep a very close watch on how security plays into all of it. And of course, because of AI and the huge effort on trying to make quick decisions, the time to insight is shrinking, which means our processors have to be faster, better, cheaper, slower, cheaper, but not slower, faster for sure. So a very interesting mix of macro elements coming together, and they are the ones driving the semiconductor innovation. Whatever we do innovation in the logic side or the memory side are driven by some of these constraints that are kind of the guiding force for making things happen. Next slide, please. And I just want to pick an example from the memory world. I won't go into the details. When we think of memory, there are 3 or 4 parameters, and memory is a big part of the semiconductor world. There are 3 or 4 things you got to keep in mind. One is capacity. Which memory architecture has the ability to have a large capacity? If you are a phone guy, you obviously want to have a lot of storage in your phone because you want to save a lot more photos locally. Of course, these days we are storing a lot more on the cloud. So clearly, that is one aspect of memory. The second one is latency. How quickly can I go and access data that no one wants to wait for data to come alive. So latency becomes a very important part. Equally important is cost. Of course, between DRAM and NAND, they have different cost structures. NAND is more expensive, and DRAM is relatively. So you have to ensure that cost structures are kept in mind. So the idea of showing this slide is the world will always have a different mix of hierarchy of architectures in memory. But one important element is 2 things we're doing in memory, right? We're trying to ensure we do a little more processing in memory so that we save on energy and latency and transaction time. We're also making sure that at some point of time, compute becomes more like our brain. A typical brain consumes less than 20 watt power and does such magic. And quite honestly, in spite of all these advancements, we still don't have chips that can get anywhere closer, which is the whole concept of getting into AGI or chips that can mimic the complex rationale and the processing speeds of our brains. That's kind of what is called, you could call it neuromorphic computing or computing closer to how the human brain works. Easier said than done. Okay. Good. We'll shift a little bit of, we'll pivot to a slightly different area now. I kept telling you how semiconductors are important. This is an interesting slide. The forecast for the total addressable market for semiconductors is expected to touch 850 billion. Some people say it's going to be $1 trillion market, right? Imagine our India balance of, our cash reserves are like 600 billion. So it's clearly a very high growth, non-linear, critical market. It took us almost 30, 40 years to get to 500 billion. The forecast is, because of the factors I've listed on the right side of the slide, new technologies, also macroeconomics, geopolitical factors. We believe that the next 500 billion will happen much faster. The prediction is we will be touching close to $1 trillion by the early part of next decade, or even as early as end of this decade. So good growth in the last couple of years, significant size. We talked about geopolitics. Every country, just like oil, wants to make sure that it has access to a fair share of design, manufacturing, and intellectual property in the semiconductor space. And because of the factors that listed again on the slide, this is clearly an exciting and a high growth market for companies and countries. Okay, next one. A slightly different view. Obviously, I have to include a little bit of a memory storage view since I play in that sector. Again, basically the same information. But what is interesting is there's a quote from our global CEO, Sanjay Mehrotra. Sanjay co-founded SanDisk, which is a pioneer in NAND flash technology, and he's been in the industry for 40 years. And what he tells us in this famous quote is, never before has he seen this kind of optimism on the possibilities in the entire continuum, starting from data center, cloud to the inference edge. A lot of innovation happening, and clearly that is leading to a lot more chips, a lot better chips, faster chips in many of your devices and applications. Okay, next one, please. And of course, you have to talk about AI. And as the chart will tell you, clearly early days in 24, 25, we're already touching 30 billion in terms of the AI chip market. These are the devices that NVIDIA, the likes of NVIDIA and AMD and others are making, Intel and others are making for the market. You can see this growing almost 10x by early part of next decade. Clearly, much faster growth than the mainstream semiconductors. This is also interesting. I will not go into the details. The interesting trend in semiconductors is the logic and the memory people used to be in their own little world, playing their own little game. But now the idea of how do you partition logic and compute and memory has become very interesting, which means we semiconductor players do a lot more collaboration with our end customers to find out what the right partitioning scheme is. And it's important because power is very important. You've got to think of some creative ways of making sure that while you improve your performance, your power targets and your power budgets are still within control. So exciting time for the AI segment for sure. And it's a very interesting play from a trend and from a partitioning, architecture, distribution of IP standpoint. Okay. A quick look at India, of course. I said that the global market is growing really fast. India is also being forecasted to touch $10 billion pretty soon. Of course, India is there's a consumption space where we are all consuming a lot of devices, cars, which have semiconductors in them. What is also happening is we have our own little unique manifestations of, for example, the two-wheeler EV segment, which is very India specific, right? You don't see that in many developed markets. So India is a great combination of traditional consumption of devices which have chips. We have newer segments, and we also have unique implementations of stack, like we've seen with the digital stack of the government of India. So still a relatively small part, and this is something I want to highlight. India is growing, but remember, the global market was almost $1 trillion, and India is still 10 billion. So good enough, but not big enough. But I think that would change with our country making rapid progress, our GDP is increasing, and of course, more and more manufacturing and design coming into the country. Next slide, please. So there has been an amazing level of talk, momentum, policy, energy in the India landscape. This is a quick snapshot of what is referred to as GCC, Global Capability Centers. Roughly what they mean is every large multinational or global company would have a design outfit in the country. MNC operations like Micron India is a part of the global Micron. Same for my peer companies like Qualcomm, Intel, NVIDIA. So 57 plus high quality semiconductor global capability centers. And this is growing very fast. And in fact, India is among the highest, among the largest and most skilled engineering talent that we have in semiconductors. So what started off in the late 90s, early 2000s as more of a augmentation center, which would actually help and assist designs getting done. I cannot speak to any company, but to Micron, I can safely tell you that's true for many of my peer companies also. A lot of the work we do in the country today is high quality IP work, designed from start to finish, complete ownership of projects and programs. You can see the distribution of the GCCs in India, fairly well diversified. It's not just concentrated just in Bangalore. Bangalore is where it all started, but now we see Hyderabad and Noida and Mumbai and Pune, other places playing a very big role in having these wonderful development centers that are designing various kinds of chips, logic chips, memory chips, analog, mixed signal, you name it. And as you can see from that distribution of talent, APAC, Asia Pacific is still small, but India and China are probably the two biggest players in the Asia market from a design and hopefully at some point of time in the manufacturing space. So a very good snapshot of where we are today in terms of capabilities to be able to design and execute on big projects. Next slide, please. Many of you are quite familiar. We had the wonderful India Semiconductor mission that was launched a couple of years back. And in the last few years, we've had lots of big announcements. Micron was one of it, or was the first mover. We decided to set up an assembly test and packaging center in Sanand in Gujarat. Then we had Tata Electronics come forth, and there have been a few more announcements since. And I believe there'll be many more in the coming months and years, because the government is very serious, and rightly so, in being able to help and mentor many of these operations as much as they can, to ensure that, because once you establish a manufacturing house, more than the manufacturing power, you bring in the power of ecosystem. And I talked about all the different vendors. Just to give you an idea, in the Sanand factory, we will be having around 80, 90, 100 vendors supporting our manufacturing operations in steady state conditions. So that kind of vendor base is critical, because not only will they support us, they'll support other players who set up shop in different parts of India. So, and the government has also signed a lot of MOUs between the state, center, and other countries. So I think India is making rapid strides. It already was a great, strong, solid design center country. Now it is making good progress to become, it'll take time. These are things that take decades. So in the next 10, 20 years, we should be very confident of becoming a very strong player in manufacturing on top of design and R&D. Okay. So this one, I thought I'll just kind of touch on, some of it has already been covered. I think the aspirations of India to become a semiconductor hub will obviously be benefiting from a very important trend. It's called the diversification of supply chain. What is happening is our customers, our vendors, our partners, because of the world that we live in and how unpredictable and complex it is, they believe they should be sufficiently diversified globally, so that, God forbid, something happens in some part of the world, supply chains remain resilient. It is actually working in India's favor. India is a stable democracy with a strong legacy of growth. So very often, companies are looking at India, in addition to other countries, as being a place where they want to truly diversify. So that is a trend that is working in our favor. It's important to have R&D and design. While manufacturing is clearly a very important element of our semiconductor strategy in the country, never forget the fact that the actual valuation, IP creation, actually happens in the R&D engineering world. So India should not be an either-or equation. It should be an and equation. We should do both R&D, engineering, design, and manufacturing well, because that complete, where else in the world can you design, manufacture, and sell at a reasonable scale? Just to give you an idea, Israel is a wonderful country when it comes to R&D, design, and in manufacturing, but it's a small country. Same for Taiwan. It's probably a powerhouse when it comes to semiconductor manufacturing, but the local markets are not big enough. So outside of US and China, India is probably the only country that has all these different elements of design, manufacturing, consumption, and market access coming together, and it's a great advantage, and we have to make the most of it. The last thing I want to touch on this slide is the skilled workforce development. It's so refreshing to see that so many government servants and resources want to understand about semiconductors. We still have shortages. I did proudly say that India has a very large concentration of engineering talent, but it's still not enough given our aspirations. And which is why companies like Micron and many of our peer companies are working very closely with the government and the industry collaboration with colleges, the top IITs and NITs, BITS, and other colleges in the country. We're trying to make sure that we are skilling and building and developing the next generation workforce. It takes a lot of time. And this capacity building, as Adil will tell you, is a slow but a steady process that has to happen for us to become a true significant player. India also has a fairly decent track record on intellectual property protection. It's very important in semiconductors because these are all secret recipes, be that be design, be that be manufacturing recipes. The country has shown a very good track record of dealing with IP fairly well. In 30 plus years of design operations, I am not aware of any significant IP leakages coming out of this country. So it builds on a very strong record that we have, and we should carry that forward as we become a more complete, comprehensive semiconductor player. Okay, next slide. So this was not supposed to flaunt about Micron, but I thought this slide is in many ways a very good proxy for what can be done in this country in the area of semiconductors. So I'll call out a few things. that are not specific to Micron. What I say applies probably to any other company that is operating in India. One is scale. We moved from almost nothing to 4,000 people in less than 5 years, one of the fastest semiconductor ramps in India's history. That's only possible when you have talent, scalable and scalable talent. Um, the Micron operation has created 1,500 plus patents, inventions, disclosures in less than 5 years. Again, a reflection of the kind of talent that we get, and most importantly, the kind of mandates operations like Micron and other companies are getting in India, because you cannot create innovation unless you have the right mandates. And of course, if you look at the number of people employed on the manufacturing side, we said we would have around 5,000 people in Gujarat once we have full-scale operations, and we'll create over 15,000 jobs in the downstream ecosystem. So clearly, it's an employment generator on the manufacturing side. It is an IP generator on the design side. And whatever you see here is essentially a great proxy or a great example of when government incentives, policy, and multinational energy come together to make things happen in the country. So see it in that fashion. Okay.
Great, Anand. Thank you. Lots, lots to digest in a very short. Lots to digest in a short period of time. Thank you for clarifying it. We are getting some questions that I'd like to pose to you. One is, can you talk a little bit about how a very small country like Netherlands has become so important in the semiconductor business? I think most people, when they think about Netherlands, think about tulips and cheese and Philips, and dikes and dams and things like that. So how did they become such a big player, and how much time did it take for them to become so central to the semiconductor business?
Very good question, Adil. One of my favorite countries to travel, and you're right. It is, which is why sometimes I worry about the usage of semiconductor as a new oil, because it is anything but commodity. Almost any player in semiconductor, one of the main players coming out of Netherlands is a company called ASML. It's a Dutch company that does a lot of equipments for lithography. And without going into their portfolio, their latest offering is an ultra, what we call UV lithography, which is a very important equipment that helps us to create smaller patterns in smaller geometries. So what we've seen is there are two ways of building. If you look at Taiwan, you look at the Dutch folks. Sometimes there's one company that kind of creates the entire vendor ecosystem. It's TSMC in Taiwan. It's ASML in Netherlands. Significant R&D over a long period of time. Imagine that the technology they had, no one else did. Even today, they are probably leaders by a long shot. The learning we should take from Netherlands is the process of building R&D and innovation is long and tenacious and steady. Sometimes in our country, we have a little bit of an obsession with very tangible, quick benefits. We want to put a factory and want to see products come out in 2 to 3 years' time. It's very tangible and visible. R&D tends to be less visible and tangible. But imagine this company, ASML, has been investing in this lithography technology for so long, and by virtue of collaborating with a lot of interesting universities and colleges. So the takeaways are collaborate more with colleges, clearly create a strong market technology differentiation, and by virtue of that, you take the entire country's economy along with you because you become so differentiated and so unique. So a lot to learn from that experiment, Adil. Did you go on mute, or am I not able to hear you well?
No, sorry. Here. Now I'm off. Obviously, AI is the flavor of the day in a sense. People are talking about AI. There's a huge investment going in there. And the semiconductor companies that seem to have done amazingly well are those that make chips for AI. Is AI going to be driving the semiconductor industry, or is it a much broader set that we're getting caught up in but that we're just getting caught up in AI?
No, good question. There will be many more levers, as I call them, Adil. AI clearly is the biggest one. I don't want to react to market attractiveness. That's, as you rightly said in the beginning, is a different category. But clearly, we believe, and at least at Micron, that AI is leading to innovation. And if something leads to innovation, use cases, workloads that are helpful in terms of automation, productivity, and so it's a matter of time before they become real. And then the famous saying about overestimating the impact in the short term and underestimating it in the long term plays beautifully with AI. We believe at Micron that that is driving a lot of our portfolio. I did not talk about this. There's a new category of devices called high bandwidth memory, which is stacking of memory on top of each other. And these memories on top of each other are talking to an NVIDIA H100 or a Blackwell processor, right? Which basically does a lot of the AI workloads today in the current. Clearly believe that AI is a significant market driver, innovation driver, and it will lead to, we are building the horizontal blocks today. What we will see a few years down the line is the verticalization. You know what? Hey, listen, I have this ability, capability on compute and data access. How do I use it in my workload or use cases to make things more efficient and attractive? And that seems like a human endeavor, is to make things better, faster, and efficient. And AI helps you get there. So very bullish, actually, on AI.
I think you've talked about the fact that to be a large player in semiconductors, particularly in manufacturing, requires an enormous amount of money. Can you talk a little bit about how much money does it take to set up one of these big facilities, and what kinds of investments are people making?
Yeah, I certainly will, Adil. Again, the numbers can vary depending on your. But think of it as this way: a front-end fab is north of $10 billion. Yeah, if you're setting up a front-end fab of some reasonable scale, at least 10 billion or more, and the costs are going up now because of the construction costs are going up across the world. And if you're setting up a slightly medium to small back-end manufacturing infrastructure, we're still talking about a few $1 billion. So nothing less than a few billion in any part of semiconductor manufacturing. And the reason scale is important is our entire sector thrives on what we call yield. It is one thing to manufacture silicon. The true success story in semiconductor is to be manufacturing at high efficiency, so we have very little wastages. Silicon is precious. Every space you see on the wafer is precious. So to get yield, it takes time, and you have to have scale. Only with scale and end-to-end competency can you achieve higher yields, which makes the economic process sustainable and viable. So that's 10 billion plus front end, many billions back end. And you have to keep investing capex because you're going to keep on needing more capacity. So you have to keep on adding on top of it.
You talked about there's already some 225,000 people involved in the semiconductor chain in India. Right. So today, we've seen in many industries there are some very large companies that spend lots of money, as you just described. And then a lot of startups that do some very interesting things that provide employment and that create breakthroughs. In semiconductor, is this just a large company game, or is this large companies, startups, everything mixed together?
Yeah, good question. Most large companies started as a small company, right? They have to start somewhere. So in some ways, Micron started as a startup 40 years back, which is kind of, but I know that the drift of your question is, it is difficult to be a startup, relatively difficult, because you have a great idea and it takes almost 2 years for that idea to show up in the form of a silicon, which has to be vetted against a market need, and then you start making money. So a traditional VC or a PE firm is excited, of course, once in a while, but this is not their preferred way of putting their dollars. They need something that can happen much faster. So what we've seen in India in particular, Adil, is we've seen a lot of startups in what we call the analog mixed signal domain, because their ideation time from idea to silicon is much faster compared to a complex SoC. If you're making a very complex chip with too many parts to it, it takes much more time to validate, test. And so that's clearly one part where Indian startups are smarter about either trying to pick something that is easier to validate and showcase as a value proposition. The other thing that we are seeing is clearly more money is slowly, the government had a program called design-linked incentives, where the government of India is beginning to put some more money into deep tech and semiconductor startups. That should help. And so I believe that you need a healthy mix of startups and large corporations. The barriers to entry are a little higher compared to software and SaaS companies, but the benefits can also be higher. I've seen so many amazing companies that have gone from nothing to being a multi-billion-dollar entity because they built something which is valuable and precious. So you can stay much longer in this game because the barriers are higher, like any business, right?
Lots of people these days, especially if they're graduating from some of our best engineering colleges, are trying to make a decision in which field to go. A few years ago, some of the brightest people decided to go into finance, right? Because that paid well and it was a great job. Then they started to go into startups. And do you see that is this an area that will attract the best and the brightest in India? If you are graduating from IIT, is semiconductors something you should be thinking about? And should you take polysilicon design or whatever it is instead of electronics engineering?
Very relevant question, Adil. I'll give you a short story. It will probably respond. It will give you the answer you expect to hear. A few years back, I would walk into IIT and do a lecture session on semiconductors and intelligent devices. And in spite of the director and the chancellor prodding the students, 30 folks would show up and then they would lose me in the middle of and no reflection of them. It's just that was not the sector that they wanted to go after. Now, what is happening in India, especially in the last 2 years, is what I call the classic lining of the planets, right? It's something that is being talked about in media. It's being talked about by the government of the day. It's being talked about by larger companies. The sector broadly is doing well for most part. So that kind of lining of planet doesn't happen. Our students are very smart. They know where the opportunity is. So my lectures at IITs tend to get a much better audience. We tend to have larger cohorts of smart people joining us. Still, it's a trickle compared to hedge fund trading, consulting, and other companies that you would be very familiar with. But I am very confident, Adil, over time, the career journeys in semiconductors tend to be very sustaining, which is why you walk into a Micron, you will find folks who've been at Micron for 20 or 30 years because they've got so much exciting stuff to do once they come in. And the stability, the growth, the career trajectory, and the compensation are all fairly attractive. So I'm hopeful. We're still not where we need to be, but I see that the momentum is shifting for sure.
No, great. I think there's a question that came here that says, in the next 10 years, can you see, or 20 years, can you see anything replacing semiconductors? Just as we have different forms of energy starting to replace oil, when do you see semiconductors peaking, if at all? Or is something else going to replace it, or there's nothing else on the horizon?
Yeah, so very difficult to have a crystal ball there. But what I see based on what I hear and what I read and what I know, we will have a lot of innovation. Silicon, as I said in my earlier comment, 90% of semiconductor devices manufactured are all around silicon. A lot of research happening in alternates. As I said, organic semiconductors, polymers, conducting polymers, compound semiconductors. They all have unique application use cases. But silicon seems to be meeting the needs for most part. The innovation seems to be around architecture. It's around bandwidth, increasing, trying to keep Moore's law, which is kind of our defining law in semiconductors, fairly relevant. So I believe that it's very hard to conceive chips going away. What will change is how chips are designed. What will change is how they are partitioned. There are concepts of chiplets, where I talked about a system on chip, which is essentially a motherhood of chip with all functionalities. Now we have chiplets, which are kind of, partitioning all these different functionalities in different parts of silicon. So the approaches, architecture, all those things will clearly see a lot of innovation and evolution. Can't think of anything beyond semiconductors at this point of time. Maybe I'm too biased, but I can't.
No, that's great. If there was a shortage of people in India for the semiconductor industry to evolve, in what areas would you see a shortage? Is it in, polysilicon experts, designers, manufacturing, quality? Where would you see currently a shortage that would hold things back?
Understood. That's a good question. I think on the design engineering side, we have shortages, but they're not coming in the way of our mandate or execution. Remember, we had a large exodus of India talent to different parts of the world. I can tell you from my own Micron example, we've had such wonderful cases of engineers coming back and working for Micron in India, from the Bay Area, from Taiwan, from Japan. So India talent is not just Indians in India, it's Indians in every part of the world. And when they see that there is a spark, there is a mandate. Just a quick story. We were in Silicon Valley a few months back. We had 300 engineers working in the Bay Area wanted to come and work in India in semiconductors. I did something similar 10 years back. I would find 10 people show up. So clearly, there is a broader India talent that is coming in. I don't see too many gaps in the design. There are gaps in manufacturing. Remember, we have not done semiconductor manufacturing at all. We're just getting started. So the whole process of training, cross-training, having some expats come, our Indian employees going and checking out our fabs in Taiwan and China and Singapore and Malaysia. That process is happening as we speak. So we see talent in manufacturing. We also see some talent in what I call the device process modeling part of it, right? In semiconductors, a lot of this is very R&D heavy. This is being able to find out what the next generation transistor material needs to be looking like. Those kind of areas are hard to find because they tend to typically align with fabs. If you don't have a fab, you don't have that kind of talent. So our talent gaps are largely dictated by what we had in the country or did not have. But I continue to be hopeful because there's one reason why semiconductors can flourish in the country. It has to be the scale and size of our talent. There's nothing else out there.
I think we've run out of time. So this has been, Anand, let me first of all thank you enormously for helping us with an overview of semiconductors. I think all of us took away quite a lot from it, and it helped us understand that India has a very good opportunity here, driven by the talent that we have here and the demand that is there. Because as you said, except for US and China, no one has both demand and manufacturing. So I think it helped us understand a little bit more about what is coming and what to do, and also some very good advice on that people should aim for working in the semiconductor industry. Is going to be a big growth employer over the next many years. So let me thank you on behalf of Capacity Building Commission and all of us for running this seminar, and I'm sure we will have a chance to talk further with you. Thank you.
So much, Adil. Thank you, everyone. Bye. Good luck.